This tutorial video will cover a typical workflow of how to render an architectural exterior shot with Maxwell Suite. For this exterior rendering, we will use Autodesk Revit, Maxwell Studio, and Maxwell Render. We will cover a step-by-step process from importing a model from your host software to saving your final rendered image. The Maxwell Suite is a powerful engine used by designers to produce a wide range of images, from architectural representation to film and TV production. For this tutorial, we will use Maxwell Studio and Maxwell Render only. As a reminder, please make sure your entire suite is the same updated version, including all of your plugins. Let's start by opening our digital model. This model right here was created by Autodesk Revit as a sample project. I will now choose the view that I would like to render. In this case, my sectional perspective. I have exported this model as a .dxf file so that I can import all of its geometry into Maxwell Studio. To do so, I came into the large R in the menu bar, click Export, and selected DXF. This model could have also been exported as a .fbx file. For exterior shots, since we can easily reset the camera and scene in Maxwell Studio, the format in which we save the file is not as primordial as in the case of an interior rendering. Remember, always save the model you would like to render in a 3D view. If you try to do this in a section view, for instance, it will not work. Let's open now our Maxwell Studio. I will click File, Import, and find my saved DXF file. Maxwell can open several types of files, and mostly the difference is how Maxwell understands them. In this case of an exterior rendering, our model from the exterior could have been read easily where it's saved in other formats. Maxwell can import all of these file terminations. With our file opened, we now can start to set up our perspectives and cameras. In our viewport, we can select perspective. This is how your model will come in. Because it came in from a DXF file, we can click on camera, and this is where our sectional perspective will be. We can also set what kind of representation we would like to have this model be. If we select Toon, for instance, this is the image that we get. Of course, these are just previews. The advantages of having a different camera than a perspective is that in the perspective, we can go in and adjust every single part of our model if we would like. With the camera, we can set up our angle, our focus, and many other options. Let's go and check out the camera parameters. The camera parameters panel represents itself grayed out until you select the camera you want to adjust. By selecting the camera, you get access to selecting the type of camera, the coordinates you want your camera to be, your focal length, shutter speed, your f-stop, your ISO. What's interesting about the camera parameters, for instance, is the preset option for the sensor. You can actually select what kind of camera you would like to use. Right now, I am using a CyberShot VSC Age X1. You can set up your resolution of your final image, your ISO, and many more options. So with our camera set up, let's start selecting all of our materials. Let's go back to perspective. As you can see, I've already added a lot of materials. If we look through my materials list here, if we look through my objects list as well, you can see that many of my objects have materials applied to them. Right now, what I would like to do is select all of these beams and apply materials to them. So let's cover the workflow for that. I'm going to select one of them in the model. And here on my object list, I have a list of all of them. It's very easy with the object list to select all of the same type of an object, just like they come in from Revit. So I am going to shift select all of the dimension number that I have in the model. To select a material for it, I can come to my material browser. On the local library, we have certain options, but they're all very limited. So if I click on web, I can make sure my login was successful to the MXM gallery and look for instance, Core 10 panels. I will double click to see a preview. If I like it, I will say import. With my new material embedded in the scene, I can now edit it in the material editor if I feel the need for it. I can actually set up the types of previews that I would like to see it in. With my material selected from my materials list, I can drag it and drop it onto my objects. Now, if we go back to my perspective view, all of those have been set a material. I can also, with all my objects selected in my perspective model, I can actually also apply to them. The risk thing about that is that you may select an object that you do not want to apply a material to. In this case, it's much easier to just select all of them in the object list. With all of those applied, I can keep doing that to all of my model. As you can see, I have done that previously. So now I can set up my camera and render it on fire to make sure it looks the way I'd like it to be. As I mentioned previously on tutorial 1, lights in your scene are also Maxwell materials. You can create them in the same way as regular materials and apply them to your geometry. Any geometry will become an emitter if it has an emitter material applied to it. For now, we will not use emitters. They will be covered in the interior rendering tutorial number 3. Let's now go over to our environment settings panel. Here we can select a type of environment based on an image, which is a high dynamic range image, or a sky. Sky is best advised. We can also choose a physical sky or a constant dome. For this rendering, we'll use a physical sky, and we can actually just load presets as well. For now, I will add the clear sky. We have access to adapting all of these values right here. Maxwell gives us all default values, so unless you have a specific reason to change all of these, it is really not recommended. We can adjust the sun settings as well. Right now, I will select a city. I will select Fargo, North Dakota. I will also set the date. With the environment parameters set, our scene is almost ready to be rendered. Let's come to our render options panel now. Here is where we can adjust our render quality and many other factors. We can set up a time for the rendering and a sampling level. These were already covered in tutorial number 1. Multi-light is a great tool, and we will cover more of it on tutorial number 3. Interior rendering. Maxwell lets you choose 2 priority settings, either normal or low. For now, we will choose normal. Quality in Maxwell is based off of production and draft. Overall, both settings achieve the same result over the same amount of time. There are a few differences between those two though. With the draft quality, essentially, it's the same algorithm as Maxwell Fire. It is designed to provide the most useful visual feedback as quickly as possible. It is also able to resolve direct light interactions extremely quickly, producing a very visually complete overall image, even at the lowest sampling levels. It also updates at a very high frequency, allowing it to be interrupted and restarted nearly instantly when changes have been made in the scene. With the production quality, the production engine does not incur the cost of spending processor cycles to update frequently. It only updates at each sampling level. Its algorithms resolve complex lighting interruptions much more quickly than those of the draft engine. Indeed, though the draft engine may feel as though it renders scenes faster, this is only actually the case when the scene contains only very simple lighting. In many cases, especially those involving more complex light interactions, the production engine can significantly outperform the draft engine. So for now, we will use a production setting. On our Output tab, we can actually select whether we want an image off of the rendered file or an MXI file. We can set up our output path. The great advantage of the MXI file is that you can import it into a post-production application even while Maxwell is still rendering. For example, you can import it into Photoshop with the Maxwell plugin and start making adjustments to your scene. After the render has finished, the Photoshop plugin will reload the MXI while keeping your adjustments. With the MXI file, you can also stop your render at any time and resume it later. We will cover more on Maxwell plugins on Tutorial 5. As you can see, we have a lot of options on our render panel to select channels, tone mapping, simulants, illumination and caustics, and etc. For this rendering, we will not be using simulants. With these settings set, I will now click Render. Maxwell Render will open in a new window. Adjusting the layout in Maxwell Render is as simple as adjusting the layout in Maxwell Studio. What I have just done was moving my camera panel to the side of the image so that we can talk a little bit about how much we can adjust in Maxwell Render. Since multi-light was disabled, I will now be able to adjust my ISO and my shutter speed directly while my rendering is going. If we look at the preview while I adjust it, you can see instantly what the result would be with different settings. And then my rendering gets updated automatically as well. A photography basic is that the higher the number of your ISO, the smaller the number of your shutter speeds should be so that the light is balanced. Here is the same rendering that I have started a while ago. As you can see, I had set a sampling level of 18. Being that right now I have sampling level of 17.44, my rendering should be almost done. If I wanted to, for instance, stop it and then resume it, I could. This is how we do so. We do not have to specify output values because we had already done it with our auto rendering. But if we did want to do that, we would click File, Save MXIS, or Save Image. This tutorial video covered a typical workflow of how to render an architectural exterior shot with the Maxwell Suite. We went through a step-by-step process using Autodesk Revit, Maxwell Studio, and Maxwell Render. Tutorial number 3 will now cover a Maxwell Suite workflow for an architectural interior rendering.